Examples, more of them. Let's get it. Let's try one out. Integral of, let's call it x squared times e to the x cubed dx. Well, this thing's pretty freaking close. We're looking for something and its derivative. And the tricky part is, it's hard to figure out what the dang functions are. We should start with the idea of finding something that's one power bigger than something else. That's usually where I start with my eyes. I don't have to think too hard on it because I have practice with it and I recognize the patterns. But at first, you might want to start with trying to find something that's 1 degree lower than the other. So we go, all right, let's call x cubed u, and let's just see what happens. Now, you have to be okay with making the wrong decision sometimes. It's gonna happen. It doesn't mean you suck, it means you're trying. Wait till you have like 7 different integration techniques. And there's no formulas or like, oh, when it's a product, do this. When it's no. There's no. You just have freaking techniques and you got to just try them out. And after a lot of practice, you start to figure out which ones go with which. Fortunately, in Calc 1, all you have is antiderivatives and substitution. You don't have the other ones like by parts and inverse trigonometric substitutions, partial fraction decomposition, impropers. I mean, there's a lot of other stuff that happens. Let's get into ours. Now let's take a derivative on both sides, and we'll call it du. And the other side, we're going to call it 3x squared, and then write your dx on the other side. And I said from before I wouldn't write it, but I mean, really, when you take a derivative with u with respect to x, it looks like this. Except when we integrate, we bring that dx on over to the other side. It's almost like we're multiplying it. I don't like calling it multiplying. It moves. I digress. So we have our x cubed. We're good to go. So if this was e to the u, we'd be fine. But what's messing us up is this damn x squared. We have this x squared dx. So let's see if we can't take this and turn it into x squared dx to where it matches. So of course we got to divide this 3 out. We got to divide that 3 out. So it looks like if we have 1/3 du, that would equal x squared dx. That's exactly what we have in blue. So we can end up getting rid of it. We can substitute in. So here it is in purple. Where we're going to substitute. So this is equal to, I'm just going to write the e. So it's e to the, and in purple we say that's going to be not x cubed. We're going to call it u. Whoa, hold on. Sorry about that. Here the u. And now instead of writing in blue our x squared dx, we need our 1/3 du right here. So I mean, you could write it like this, but this sucks. I mean, you start to get used to it. If you ever have a coefficient, you just slap it out front. But there it was. We just replaced it. Now everything's in terms of u, and we already know the antiderivative of this. So once we clean it, we bring that 1/3 to the front, and we say it's e to the u du. Well, shit. Finding an antiderivative of e to the u, that's no problem. That's just e to the u plus c. And there's no bounds, so we don't have to worry about plugging anything in. This is our indefinite integral. Now we got to look back up top and go, shit, we can't leave that in terms of u. We got to leave it in terms of x's, and u is just equal to x cubed. Therefore, our answer is 1/3 e to the x cubed plus c. And we got it. Oh, substitution. And if you think this is nuts, wait till you get into it. Calc 2 is a much, much more challenging and fun game. I'd much rather solve Calc 2 problems than Calc 1 problems, as far as a game would go, because there's so many different options. Okay, continuing on, let's get into it. Let's start going. Let's look at this. Let's go find the integral of secant squared of the square root of x all over the square root of x dx. This is rough. All right, so we typically want to look inside of functions or in denominators. Now we see here, now I'm going to go the wrong direction. Do you mind? Would you mind if I go the wrong direction real quick and just do this and say, I'm going to let u equal the square root of x, and then coming back over and going secant squared of u over u du. You can't do that. We needed to take its derivative. So we're actually only going to substitute for one of them. It's really weird. I'm actually just going to say that we're only going to substitute for this one here. And I'm going to write it out just a tad bit differently. This is secant squared of the square root of x times 1 over, in hopes that we can see it a little bit better. So let's take a derivative on u. And if you don't have this, come on. Derivative of the square root of x is 1 over 2 square roots of x dx. Well, oh shit, that's super close. The only thing that's different is we have this 2. So why don't we multiply it over to the other side and say that 2 times du is the same thing as 1 over the square root of x dx. That matches. This matches. Bruh, we're ready to go. We got this. So let's start substituting in. We're like secant squared of, and instead of writing in the square root of x, we're going to write in u. All right, boom, get that u in there. Now, instead of writing in 1 over the square root of x dx, we're going to write in 2 times du. So I'll write it in kind of weird, 2 du. But the 2 goes over here. All right, we don't want that shit hanging out there, so let's not write it. 2 times the integral of secant squared of u du. We all know the antiderivative of secant squared. That's tangent, so you get 2 times tangent of u plus c. One more time, you did not start in terms of u. You started in terms of x's. Let's end in terms of x's. Now we just sub it back in and say it's 2 times tangent of the square root of x plus c. And if you're one of those that really likes correct answers, you know what I mean? Like, you're like, do you know what I really like? I really like it when I get A's on worksheets that I get to take home and pretend that they're tests. I really like that. See, you know the way you're like, you know what I'm better at? I'm better at derivatives than I am at integrals. I like integrals more. But you can't stump me on a derivative. I will get it. Give me time, I will find it. You sure as hell can stump me on an integral. So the point of this is, just take a derivative on this thing and see what happens. So if y equals 2 times tangent of x to the 1/2 power, just a quick check, plus c, who gives a shit about the plus c? Y prime is equal to 2, so that'd be secant squared of, leave that shit inside of there, and then multiply by the derivative of it. So those go away and you get secant squared. Sorry, change it to a 1/2. I don't know why I did that. Oh, no shit, that's where we started. You get to check your answers. Just take a derivative on your answer. Make sure you get back to the integrand. If you did, yay, do the happy dance. Cool. There's one. Now, can I show you one? This is embarrassing for me. This is embarrassing. I get very sad when I think about this. This is no bullshit. I'll never forget it in my entire life. Calc 2, first test. Professor Lucero pops this one on there. Only problem I couldn't answer. It makes me so mad to this day. I'm like balling my fists. I'm so freaking frustrated that I missed this. Now this is a little weird. This one's weird. And how I got stuck is I went, well, I had a rule. It's like whatever's underneath the square root, I'm going to call that u. And let's see what happens. And I was like, all right, so let u equal x plus 1. And then the derivative on u is equal to dx, right? Because the derivative of x is just 1. So 1 times dx. I was like, shit. Well, where's the x to get rid of? I can't do anything to this. I can't manipulate it. I kept going back and forth and being like, I have x times the square root of u. shit, I can't do this. And I couldn't figure out what the hell to do. We have the ability, whatever you call you can manipulate it. You can move it around. Because we're going to do this. It's going to be the square root of u underneath this thing. And this is going to become a du. But we're going to mess around with this x, and we're going to solve for it right here in terms of u. So this is our game. If we would have taken this and just moved it over, what if we subtracted 1 over to the other side? Wouldn't we have u minus 1 is equal to x? We can now take this thing and pop that in over here. And you might be thinking, well, what's that do? Well, let's rewrite it. U minus 1 times u to the 1/2 power du. Let's distribute it in. It's just a power rule. U to the 3/2 minus u to the 1/2 du. Oh shit, just a power rule. Gosh, this problem pisses me off. I'm going to do this one with you. I'll probably give you more constants and stuff. I'll give you a 3x plus 4, and then on the outside make it like a 7x, so you have to deal with all the constants and fractions and shit are going to happen. But it's going to be the same freaking problem. And we get that this is going to be, so that's 2/5 u to the 5/2 minus 2/3 u to the 3/2 plus c, and then we got to back, so we got to put that u back in there, don't we? Got to put that in, so let's solve. We get 2/5. Our u was x plus 1, so we get x plus 1 to the 5/2 minus 2/3 x plus 1 to the 3/2 plus c. That's a beast. Indeed, that is a beast. So you want your last quiz problem? All right, hidden quiz 5. Problem number 2. Decided to throw this thing right at the end. Well, here it is. All right. It's tricky. It's tricky. You might have to do something twice. I'm going to push you on this one. You ready? Okay. Sine of x over 1 plus cosine squared of x dx. This is above and beyond. This is more than what I've shown. There it is. There's your second problem. This is the last quiz problem. So for hidden quiz 5, there's problem number 2. Good luck with it. It's going to require some work, a little bit of thinking, a little bit of thought. See you.